Welcome back, students. In this video, I will discuss about the heating effect of current. We are close to end of this chapter. So what is heating effect of current? When a current flows through a conductor, like a wire, copper wire, it produces heat. This is called as heating effect of current. So why or how that heat is produced? So you know that the current flow happens due to the flow of electrons. When electrons move, they collide with atoms of the metal. This collision causes the atom to vibrate and produce heat. Basically, you can think you're rubbing both your arms. There is a friction and there is some amount of heat. You can crudely compare this with that example what I gave. Because of the if there is free flow of electrons, there will be not much heat. If the electrons are obstructed or it's not able to freely move, it hits the atoms, then there is heat produced. So this I'm bringing back the video which I shared in my first lecture on physics. This is how the current flow happens. These are the free moving electrons, whatever you can see here. These are the free moving electrons and the atoms are here. So on the surface of the wire, you can see heat is produced due to resistance. Resistance is nothing but opposition to the flow of current. The electrons are not able to freely move. Because the electrons are not able to freely move, there is a heat produced. Even in conductors which have very low resistivity, still there is some amount of resistance which produces heat. So coming to an important topic, Joule's law of heating. There are multiple problems asked in this topic, so kindly pay attention. So whenever electric current flows through a conductor, heat is produced due to resistance of the wire. This heating effect is called as Joule's heating effect. The amount of heat so produced depends upon three factors that you see here. The first factor is the square of the current flowing through the conductor, that is I square. The second factor is the resistance of the conductor. And the third factor is the time for which the current flows through the conductor. All are directly proportional. So combining all three together, you get the heat produced is equal to I square RT joules. Now, combining all three, I told you we are getting I square RT. The key point to notice is R and T are linearly proportional to the heat generated, means double the amount of time, double the heat produced. Double the amount of resistance, double the heat produced. But I, current, has a square relationship. So double the current, the heat increases by 4 times. Okay. So this has a bigger effect on the heat that is produced. So there are some practical applications. See, if you take your electrical iron box, toaster, electric oven, all these work on the principle of Joule's law of heating. So there the materials are with very high resistance. So in the equation I square RT, this R is very high. Because the R is very high, it produces heat. The resistance is very high. The current does not freely flow through the heating element which is produced in this, which is present in this devices. There is a heating element which is present in these devices, which has a very high resistance. Because of high resistance, there is no free flow of current, and there is a lot of collision within the atoms and the electrons that causes the heat. Another practical application is your electrical fuse in electrical circuits that is present to protect the electrical circuit or electrical appliances from a large current passing through it. So again, this works on the principle of heat due to high current. The same equation I square RT. When I increases, we have a square relationship. I told you right, it has a square relationship. Suddenly, instead of 1 ampere, 2 ampere flows, the current increases. I mean, the heat increases 4 times, and because of the heat, the fuse will blow. How the electric fuse blows, that's a more practical demonstration in the next video. There is another application which is heating produced due to light. So earlier, a couple of years back, there was tungsten filament bulbs. The bulb purely glows because of heating. It's a very high resistance material and has a high melting point. Because of these two characteristics, it when current flows, it burns and gives the brightness. So in the next video, we will discuss more about the practical application of heating effect in fuses. Thank you and bye till then.